Welcome everyone to this reactor session entitled Take Your First Steps with Python. Very excited to be here with you and get a chance to spend the next 60 minutes or so together. Very glad that you're here and hope that you get a ton out of this. Sounds like there are a lot of people on this session, so I'm very excited to kick this off and hopefully we'll all learn something. So welcome, great to be here with you. So just quickly, quick sort of introduction or cover off on what the reactors are, right? The reactors are really opportunities for us as community members to come together, right? Meet, network, connect, and learn from one another. And there are a ton of topics, technologies covered off during these sessions. And I think there are tremendous opportunities to meet and, sort of expand our network of technological contacts and, really help us kind of as we all are walking along this journey of technology innovation. So, again, great to have you here. One of the great things about reactors is there are options available across the globe. And, in this pandemic sort of time that we're in right now, we're forced to meet virtually, but that's okay. It's still a great and very effective, I think, approach. Hopefully there'll be a time again when we can get back together in person. But just right now, know that there are a ton of options available to you globally. So glad that you're taking advantage of this. I try to take advantage of it myself as well. Excuse me, a couple of housekeeping items. Please, if you have questions or concerns, comments, leverage the chat window, leverage the Q&A window. We will have someone monitoring that. We'll try to keep an eye on that as we go. So if you are having any trouble hearing me, or if the screen resolution is not large enough, please let us know that as well, and we can adjust accordingly. So let's go ahead and get started. So take your first steps with Python. A little bit about me real quick. My name's Alan Sanders. I am a senior cloud architect operating out of the United States in the state of Ohio. I've been in architecture, development, and design for about 25 plus years. Have worked in a lot of different verticals, have worked in some really large companies and some small companies, and have done quite a bit of consulting as well. One of the things that I really want to highlight, though, that I hope will be beneficial to you is that I have a real passion for learning, right? And that's not just yours, that's my own as well. One of the great things about this particular field, this industry, that I love is that I don't ever foresee waking up one day and saying, hey, I've learned everything there is to know about technology, right? There's always going to be something new. There's always going to be a new challenge, and that's what I love about this. So I'm passionate about learning myself and yours, and that's what I'm really hoping happens during our time together today. Quick rundown of our agenda. Excuse me. We're going to do just a brief introduction. We're going to talk a few slides, and I'm going to be just doing some very quick slides, pretty foundational stuff, because I want to be able to get to kind of the meat, which is how do we set up our environment, and let's do some Python coding, right? But we'll talk about programming Python. We'll talk about setting up your environment for Python development. We'll go through some code examples, talk one or two challenges depending on how much time we have, and then sort of finish up and wrap up with a summary. So without further ado, let's go ahead and get rolling right into it. Okay, so why Python, right? A lot of people here, obviously Python is a very popular language, and you might ask sort of why, right? Why so many people interested in Python? And I think it's a few things, right? There's a relatively low barrier of entry. It's a language that you can start with simply and do a lot of things without a whole lot of effort, but then quickly ramp up to more complexity as you're ready and as required. It's open source, so it's community maintained and free. It's supported on multiple platforms, which is really key in this day and age, right? Where we don't exactly know what platform folks are going to be running their systems on. Supports multiple application profile types and use cases. So huge in machine learning and data science, Python is, their games, APIs, pretty much any type of application profile or use case, it can be and probably has been implemented in Python. And one of the great things about Python is it offers an extensive ecosystem of importable libraries and frameworks that allow you to build on top of Python, right? So you start with Python as a language, and then you import other libraries or frameworks that allow you to build on top for additional capability. So really helpful, and I think great in that respect. Learning Python. So what are we kind of thinking about when it comes to learning Python? Well, one thing I want to mention is that you should focus on Python 3 instead of Python 2, because that's really the accepted standard right now. That's really what we should be focusing on. That's what we'll be focusing on today. The Microsoft Learning Path, which we're going to walk through in a bit here, is a great place to start, right? The Microsoft Learn platform does a great job of pulling together contextual documentation with exercises and tutorials that you can walk through, and then marries those together, right, with knowledge checks. You can earn points, and with those points you can earn trophies, which is kind of fun. So the Microsoft Learn platform is a great place to start, and specifically the learning path on Python that we'll cover off during this session. At www.python.org, there is a beginner's guide under the documentation that you might find helpful as well as a number of books and tutorials and sites. But really, to learn a language like Python, it's practice, 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 right? So what we're going to try to do today is position you for an environment that is ready for build going forward, and then you can kind of build on top of what you gather during our session here today. All right, programming in Python. So a couple of foundations. Again, I'm not looking to take a whole lot of time with this because I really want to get into a demo that we can walk through. But foundationally, right, we're talking hardware and software, right? Hardware is our physical computer. It's our CPU or central processing unit, our RAM, random access memory, our hard disk, keyboard, printer, or SSD, right? That's our hardware, right? That's the platform that we are operating on. Software are the programs that we execute on top of that hardware, right? Whether it's a spreadsheet, word processor, or it could be an integrated development environment, which we'll look at here in a bit, right? But we build software to run on that hardware, right? So we have to sort of understand how the two of those things work together. Programming languages, right, are defined by a specific syntax and a specific set of syntax rules. And syntax is really just that. What are the rules of that language? What's the grammar of that language? What makes code in that language valid versus invalid, right? That's the syntax. With the programming languages like Python, we can create code, right, that is in a human readable format to outline the program's instructions, right? To define what we want the computer to do, we can use a language like Python to do that. And then, right, that can be translated, because the computer's not going to understand the human readable format, right? The computer needs it at its simplest, right, in zeros and ones. So that human readable format can be translated, right, into something that's understood by the computer. That's where a compiler comes in, right? Compilers build code, right? Build your code, check it for errors, validate for any syntax violations. It can convert your code into that format that is well understood by computers. Optimizes the code in some cases for deployment or distribution, right? Because if we have it like this, which is easier for humans to understand and consume, when it goes to the computer can take it in a lot more compact formats, right? So a compiler might help us do that. In a lot of cases, with a lot of languages, each change to the source code requires that you recompile. And in a lot of languages, that compiler needs to be targeted to the platform you're running on, right? So if you compile code for Windows, it has to run on Windows versus Linux or Mac OS. Well, Python is a little different, right? Python as a compiler right? But it leverages something called an interpreter, which is really important. And that interpreter is really just a layer that operates on top of the platform layer, right? Python compiles code to a format that, rather than the computer understands, it compiles code to a format that the interpreter can understand and run. Why? Well, some benefits there, right, is that source code is going to be compiled each time it's run, right? So we don't have to do necessarily a separate step to cause that to happen. This enables interactive coding, right? Where we can actually code line by line, and we'll look at that as we get into the exercise. And then this is the key one, right? It enables code written on one platform, Mac, Windows, Linux, to run on another platform without recompilation. So it really gives us flexibility in terms of, you know, write once, run anywhere kind of idea. So, you know, that's the Python interpreter. That's how Python's a little bit different. Briefly, let's just talk real quickly about the development process, right? So when we walk through the development process, typically what we do is we analyze and plan, right? We gather requirements to understand what the software is supposed to do. We design it according to those requirements. We build it, right? Write the code. We test it, deploy it, right? So that users can use it. And then we operate it, right? We might monitor it, address any runtime issues that are encountered, or any failures that might be encountered for a given request, right? And then there's kind of a sequential flow that these things work through, right? But another key point to this, right, with any, I think, good development process, especially if we are talking agile, which is a very popular framework for running projects, software delivery projects today, we have this concept of maintain, right? As the business innovates, as technology innovates, we may need to make changes or may want to make changes to our software to take advantage of that innovation and to evolve our software into an even more useful product, right? And that maintenance can basically turn this into a cyclical or iterative process, right? So the life cycle of software is actually multiple of these cycles, right? And that's kind of what we're talking about. And again, this is just foundational stuff, right? We're going to get into Python itself, but this hopefully gives you information that is helpful in terms of just generally speaking how the process works. So any questions or comments about that? And stepping up from running pieces of code for, we did get a question, stepping up from running pieces of code for stats on Jupyter Notebooks, what is the next best developer environment to choose? Well, if you're talking platforms, you have a lot of different options available to you, right? If you're talking IDEs, we're going to talk about Visual Studio Code today as a valid platform that you can leverage. But in terms of, you know, it depends on what you're going to be doing with that system, right? How much you're going to be doing, if it's going to be dedicated specifically to, you know, data science and data processing, then, you know, you may not need a heavier piece of equipment. But if you're going to be doing more than that, then, you know, you have options for a few different ways that you can go in terms of platform and then also development environment as well. So hopefully I understood that, addressed it. If not, please ask a follow-up. And anyone else, if you have questions or comments, you know, please leverage that Q&A as well. All right. So let's go ahead and move right into sort of the kind of demo. And it's really going to be, what I want it to be is something that we can work on together, right? And to do that, let me grab this link and put this in the chat. All right. So if you hit that link, right, we will have an opportunity to walk through some things together, right? So we're going to talk about setting up our development environment first, right, which is going to include installing Python 3 or verifying that we have it installed. We're going to talk about testing it using interactive mode. We're going to look at installing Visual Studio Code, and then talk about some configuration that we can do within Visual Studio Code to facilitate Python development in that IDE. Okay, so we'll go ahead and launch this link. It's opening on my other monitor. Let me pull it over. So this is the Microsoft Learn platform, right? And this is the specific learning path that we're going to be covering off on. Okay. I do see a question. Can you recommend a good course on Python for beginners? I would start with the beginner's guide in the python.org site, but then also there are other courses that you can cover off in Microsoft Learn, and then platforms like Pluralsight, for example, or Udemy might give you some options as well. Okay, so thanks for that question. Keep those questions coming. Love them. I'll try to keep up as we go and keep an eye on them. That's why I keep shifting my eyes to the right. We're going to be walking through this learning path, right? But only the first 3 modules, right? Because there's 10 modules to this, and we just don't have enough time to go through all of them. Now, I'm going to encourage you at the end of this to go back and go through the rest of them, right? But what we're going to do, we walk through this first module, what is Python, and I just sort of did that with some of the slide that we just reviewed, right? So I won't go into that. Let's go ahead and jump down to this, set up your Python beginner development environment. Okay, and we're going to jump down to this install Python 3 link. So again, if you're following along, feel free to do that. And the nice thing about one of the cool things about Microsoft Learn, especially in this particular course, is look, there might be instructions specific to your platform for setting up Python, right? Linux might do it one way, Mac OS might do it another, Windows might do it another, right? But here you have information that is specific to your target platform. I'm going to walk through this for both the Linux and Windows platforms. I don't have a Mac, so I can't do the Mac one, but I just want to show you some differences and nuances between the two. So let's go ahead and look at getting Python installed. I am going to use Windows Subsystem for Linux, which allows me to run a native Ubuntu image on Windows 10. Let me increase that so that it's a little easier to read. And so when you're in Linux, right, if you want to check for the existence of Python to see if it's installed, you can type Python 3 -- version. If you get back a response that is some format of Python 3 dot blah, 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 right, then you have Python installed. If you get back an error message that says that's not recognized, then you may need to, you'll need to install it, right? And in Linux, at least in Ubuntu, for example, to install, you can simply, and this is called out in the module, right? But you can do a sudo apt-get update to update our package indexes. And then we can do a sudo, which is super user do, apt-get install Python 3. And now what it might come back and say is, hey, Python 3 is already at the newest version. It might say, hey, there's a newer version. Do you want to upgrade? Right, you can do that. And then as general housekeeping, what you'll want to do is a sudo apt-get upgrade to see if there are any packages that need to be upgraded as well. Sometimes existing packages include, security patches and fixes that would be beneficial to have. So just as far as care and feeding for your system, right, those are the steps that you can walk through. Again, once I complete those steps, I should be able to type Python 3 -- version and see a message like this. Okay. So that's installing or verifying installation of Python in Linux. For Windows, I'm going to navigate to the command line. Open a command prompt here, make this a little bigger. What I can do here for in Windows, it's a little different, right? I can do py -- version, and then I should again get back something like this, Python 3 dot something, right? If I don't receive that, right, and it's not installed, then for Windows, the easiest way to install is to navigate to www.python.org. And then you can see here that there are multiple downloads available to you. You can go directly to the Windows page, or there's a helpful button right here, right, that shows you, there's a helpful button here that you can use, that you can use to download the installer for Windows, right? And when you download this, it's just going to bring you an executable installer that you can walk through to install the language on your machine. So do we have a question? Why Linux, not Windows? Well, hopefully you'll have a chance to see both here. So that's what I'm trying to walk you through both. So that's how you would install Python on Windows, is with this installer, right? And after you've executed that installer, again, you should be able to come back to a command prompt and type py -- version, see this message. Okay, so that's the first step, making sure that we have Python installed. I'm going to continue. Again, I know I'm moving a little quickly. Try to walk through it with me. We have limited time, but do the best, and you'll have an opportunity to kind of follow up on this after. So, as I said, with the Python interpreter, you can actually execute code interactively, right? So the way you do that is, if you're in Linux, you can type Python 3, but instead of the -- version, you just hit enter. That takes us into an interactive command prompt, right? So I can type any valid Python code here and execute it. The interpreter will execute it on enter. So if I type print, which is a valid command, hello reactors from Linux, echoes that line, right? It executes that command interactively. So that's one option you have for Python, right, is interactive. And that's a good choice if you want to try something, right? You want to check out a command or test a command and approach, you can use interactive mode. To exit from interactive mode, you can type exit, open, close, parent. Windows, very similarly, we type py without the -- version, and then we have an interactive command prompt here as well. Hello, reactors from Windows 10. And then we see that replicated here. If I type exit, open, close, parens, I can leave that interactive command. So again, one of the benefits of Python is the ability to sort of execute commands interactively if you want to test something or try something. All right. Next, we're going to talk about Visual Studio Code. Visual Studio Code is, in my opinion, an awesome IDE, or integrated development environment, that you can use for all kinds of languages, right? The great thing about Visual Studio Code is that it's free, it is very user-friendly, and it has a ton of available extensions. There's a marketplace that you can pull extensions from to make, from a contextual perspective, to make the coding easier based on the language you're using, right? So if we're using C#, there are a set of extensions that are specific to C# and make it easier to code in C#. Similarly, in Python, there are extensions that help facilitate some of that as well. So the easiest way to install Visual Studio Code, and I already have it installed, but the easiest way to install it is I just go to my browser and I type download Visual Studio Code. And I should come to a link like this that will provide me what I need in terms of if I want to run an executable for Windows, I can download here for Linux or for Mac OS, right? So an installer that we can leverage to execute and build out our Visual Studio Code installation on our system, depending on platform. So as you walk through that, once that completes, right, there's a couple of ways to get to Visual Studio Code. You can, open up the start bar and type Visual Studio Code and access it here. But what I like to do is, so I'll start from here. If I make a new directory called Python Demo Linux, I navigate to that directory. From this directory, I can type code dot, and it will automatically launch me into Visual Studio Code, but in the context of that new folder, right? Whatever folder I started it from. So I like that. That's an easy way for me to get to the location that I'm targeting, right? And here's Visual Studio Code, right? Over here, we have access to multiple extensions. And what I can do is from here, I can type Python. And what we're looking for is this one that's put out by Microsoft that has probably 26+ million installations. We can grab that one and choose to install it. That's how we install the Python extension, right? And this extension, the benefit of this extension is it gives us, interactive real-time syntax validation, right? We'll point out errors in our code as we're typing, right? It includes IntelliSense, which helps us autocomplete statements. So as we type a few characters, it will suggest potentially matching commands and allow you to easily and quickly write code, right? So very, very beneficial, very helpful. And there are extensions, again, for multiple languages, right? Python is just one. So we've got the extension installed here. If I go over here to my Windows environment, right, I can make a new directory called Python Demo Windows directory. And again, on Windows, just like on Linux, I can type code dot, excuse me, to launch Visual Studio Code for Windows in the context of that folder. So similarly as with the Linux version, right, there's an extensions area. I can search for Python, and then I can install that extension in my Windows instance of Visual Studio Code. So, the point there is we have access to Visual Studio Code. We download that, and then we can install extensions on top of Visual Studio Code that will help facilitate our Python development. So while that's completing, let's go back here and look at where we are. All right, let's next talk about, we did the extension, and let's go ahead and do our first Python script, because I want to talk briefly about pylint. That's complete. All right, so let me go to Linux first. Get Python Demo Linux. You can see from the top which one we have. In a minute, when we start working on exercises, I'm only going to be working in the Visual Studio Code instance running in Linux. But as you can see, they're the same, right? Once I get inside of Visual Studio Code, it really doesn't matter other than maybe the type of command I'm using to run Python. But there's even a button that we can use to facilitate that execution that doesn't necessarily require us to know, differences between the two. So here, if in this folder I right-click and choose New File, I can type initial-script.py. Python scripts end in .py. And here I can simply type print this line is wrong. Save that. Now, as you start working on a Python script within Visual Studio Code, you may have a couple of messages come up down here at the bottom, right? Is there enough time to do a GitHub example? Unfortunately, no. Sorry. Yeah, I wish we could, but yeah, we're not able to, unfortunately. Great question, great call out. What you might see is a couple of different message boxes pop up here, right? One of them might be that you need to select an interpreter, right? We said that there's a Python interpreter that executes our code, right? That is used to execute our Python code. You might need to select an interpreter, right? And you can do that down here, right? Or it'll ask you if you want to select if you get that message, right? So here it's going to show you all the versions of Python you might have installed. I only have one in my Linux environment, so that's the one I'm going to select. But what you might notice here, right, is we have red squigglies because we're using invalid syntax, right? This line is not correct. It's not coded correctly according to the syntax rules of Python. So you have to configure anything in VS Code concerning the proxy. No, unless you are, unless you're hitting something on the internet, I guess you might need to. Really depends on your network setup, I guess. If you have access from a browser perspective, then you should have access from Visual Studio Code for anything that you might need to link outside against. So, you know, running through this, we see that we have an error. Now, if I go to View, Command Palette, this shows me commands for any and all extensions I might have installed on my system, right? And if I type Python, for example, it's going to bring up all of the all of the commands that are associated to the Python extension that I installed. So I can select this linter, right? And I can select pylint, all right? So let's talk about that. What is a linter? Well, a linter is basically a utility that runs interactively against your code to, again, show you where you have syntax errors, right? Where you might have violated the syntax of the language. And it might, depending on the way the linter is configured, it might provide you with, you know, helpful suggestions that you can use to, you know, correct the error. So in this particular case, I'm going to make a change and save. And what you might get is this message, right? You might get a linter, pylint is not installed. Pylint is typically the default linter. So all right, I got an error concerning marketplace error while loading extensions. Yeah, I'm not sure. To my knowledge, you shouldn't have to set anything up, or maybe there is something firewall-wise that is preventing. I've not encountered that, so unfortunately, I won't be of a lot of help there, I guess. What are the main benefits of Python, let's say, over Java? Well, Python is sometimes considered a little bit easier to get into, right, from a beginner's perspective. But past that, it really is right tool for the right job. And in some cases, it's preference, right? If you have more of a preference for Python, you can do a lot of powerful things with Python, just like you can do a lot of powerful things with Java. So I wouldn't really say one is better than the other. The only thing I might call out is that in some cases, Python is considered a little bit easier from a barrier of entry perspective to at least get started, right? So that's where I would see the differences. On this py lint here, we see that it shows that it's not installed. If I click install, I might receive another error in pip that says, another error in Visual Studio Code that says you don't have a pip installer. So if I go to View, Terminal, from here I can type sudo apt-get install python 3-pip. Pip is just a package manager for Python libraries, right? So I can install pip, and then once I have pip in place, I can run sudo pip3 install pylint, and now if I select my linter, select pylint, if I go in and peek this problem now, right, it now gives me two problems, right? The first one that I had previously, but now I get one specific to pylint, which says, hey, you're missing parentheses in this call. Did you mean this instead, right? So the pylint linter just gives you maybe a little bit more information in terms of what your error might be, right? So you can correct, obviously, by putting parentheses around, and then that error should go away. Okay. Let's switch over quickly to the Windows instance and talk about this as well, and then we'll get into some exercises. So over here, I'm going to create my initial -script.py, just like I did before. I'm going to type print, this line is wrong, and save it. I'm going to select my linter, right, as pylint, and then save. I might get another message here, right? The reason I wanted to cover off on this with you specifically is you might receive an error. So if you're in Windows, right, you might receive an error. If I hit install here, right, which I would hopefully be able to use to automatically install pylint, you may receive the same error that I received, which looks like this, right? Something didn't work, right? So if you do receive that in Windows, what you can do instead, and I'll post this into the chat, py-m pip home-u. And what this command is going to do, let me post it and then I'll cover off on it briefly. This command is going to use the Python package installer, just like you had in Linux, but now you have it in here in Windows, right? This is going to execute that, install pylint. The -u says, if it doesn't exist, install it. If it does exist, upgrade it. And the --user says, keep it specific to the current user. Okay, that's the statement you can execute to install pylint. When I do that, again, when I go up and select my linter, make a change, and save. Now, if I go in and peek problems, I should see again two problems, right? One of which is the same pylint message we got in. So I know I'm probably running at breakneck speed here, but what I wanted to do was just cover off on that sort of configuration, right? What does it look like to set up your environment, right? What does it look like to install the extensions that might facilitate Python development in VS Code? And what are some nuances potentially to pylint depending on your environment? So I did want to at least cover up on those. Someone did ask a great question. before we move on to the next set of activities, if I want to develop my programming skills, should I start with Python, Java, or other programming languages? I would say that Python is a great place to start, right? Because of that low barrier of entry. Now, having said that, I think it's good to learn multiple languages, right? But sometimes there's only so much you can kind of absorb at a given time. So I might recommend that you start with Python, right? And continue to work there because you're going to learn some fundamental concepts about programming, right? That will apply across multiple languages, like data types, and then, inputs, outputs, processing. You'll learn about that, and there will be some applicability in other languages. It just might be with different syntax. Python is also a little bit more forgiving in terms of data types and data declarations and how you sort of, it's not in terms of how you define your variables, for example. It doesn't necessarily require you to specify a type. It will infer the type from the value that variable takes on, which can make it a little bit easier. So I would suggest, yeah, Python is a great place to start. Get good with Python, get familiar, right? And then look for opportunities to expand into other languages as well. I like to have, I code in a few different languages. So I like to, get some exposure to a lot of different areas because it keeps it fresh, in my opinion. Okay, so we walked through installation. I'm going to close down my Windows instance and just focus specifically in Linux. But again, for our purposes, there's really not, close this because I already addressed that. There's not a whole lot of difference at this point, right, at this layer, once we're in Visual Studio Code. So let's see how we're doing on so we got the extension installed. Okay, so we finished that topic. Let me move back. So we've completed our Python beginner development environment. We completed that setup. What did we do? We installed Python, or made sure it was installed. We installed Visual Studio Code, and we looked at selecting the interpreter and assigning adding the Python extension to Visual Studio Code, and then adding the default pylint linter to Visual Studio Code. So that's what we did there. The next thing we're going to do is look at creating our first Python programs. Going back to our presentation here briefly. So we're going to look at 3 examples: hello world, hello name, and adding number. And this will give us a chance to sort of explore some of the nuances of the Python language. So do, and again, you're able to follow along with these as well within the Microsoft Learn platform. But let's go ahead and start with hello world. So I will create a new file called hello world, hello-world.py. And here, very straightforward, right? I can type print hello, and instead of world, I'm going to say hello reactors from VS Code on Linux. Now, we saw the interactive mode, which allowed us to type a command, hit enter, and then have that command immediately executed. This is different, right? We're creating a script file that we're then going to run through the Python interpreter to execute. To do that, we have a couple of options. Here in Visual Studio Code, it gives us this nice button here, right, that runs the Python file in the terminal. So if I click that, it should run, right, hello reactors from VS Code on Linux. Now what you might see here is basically to run this, right, I can type Python 3 and then the name of the script, right, and that executes it as well, right, which is really what that play button is doing. But I just wanted to demonstrate that you could do that sort of separately as well. If you were running in Windows, if you're on the Windows version of Visual Studio Code, then instead of Python 3, it would be py hello-world.py to run the code, right? To execute your Python code. Very, very simplistic example, but it really just gives us a chance to see a couple of sort of nuances of executing a Python script, right? We saw the interactive mode, and now here we see building the script and then running that through the interpreter as a script file. Okay, the next example is hello name. So let's go ahead and create a new file here called hello-name.py. Let me close hello world. And with hello name, what we're going to see is that we can actually start to gather input, right? So any programs to be effective, right? I guess not any program, but many programs, let's put it that way, right? To be effective, might need to gather input from the user, right? Do some processing on it and then provide output accordingly. So what we can do here is I can print a prompt, right? That says, enter your name. And declare a variable in Python by simply giving it a name, right? And it could be anything. It could be X, it could be Y, it could be name. You should use meaningful names that aren't super long for your variables, right? But meaningful names that make it more readable. And typically we use dashes underscores in our variables if we need to separate words. But I'm just going to use a name variable here. And I'm going to set it equal to a method call, input. Input is a method that I didn't create, right? It just comes as part of the standard library with Python. And it is utilized to accept keyboard input into the name, right? So name is going to equal the results of my input. And then I can turn around and print output that says hello. And then I can use the plus sign to concatenate strings, and I can add in my name variable, right? So output a prompt, gather input for the name, and then turn around and echo that input accordingly. So let me save that. Here, if I type Python 3 hello name.py, it's going to ask me for my name, Sanders, and then output that message. Now, one thing to be aware of is that there could be different versions or different overloads, they're called, right, of the same method. All right, so you might have different versions of the input method. One version of the input method allows me to actually put the prompt in here. If I get rid of this first prompt, execute, it will, take my input and produce the output. Now you'll notice with the prompt here, because it keeps it on the same line, we might want to do some formatting by putting a space in front of the input so that it's a little easier for the user to make a distinction between the prompt and the information that we're asking for. Okay? So that's the hello name, and it gives you a chance to sort of get some introduction to variables, right? We have a name variable. We have an input method that allows us to pull keyboard input from the user. That input method, we didn't have to write it. It's included in the standard Python library. You can import other libraries, right, that include other functions that you can use in a similar way. And then we see here how we can output that text. All right, one more exercise here, and it's going to be called addition. This one gets a little bit more interesting. We'll look at why. So I'm going to create a variable called first number, and I'm going to set it equal to input, enter the first. I'm going to create a second variable called second underscore number, set it equal to input, enter the second number. Now I can create a third variable called sum and hold the result of the addition of those two numbers. Okay? And then finally what I can do is print the result. So we're going to take in, we're declaring two number variables, right? We're accepting input for them, adding them together, and then outputting the result. Well, kind of interestingly though, if I, let me clear this and then run it, Python 3 addition. My first number, I'll use 42. My second number, I'll use 99. Wait a minute, right? It's not 42 plus 99. It's not the addition that I expected. Why? So the reason why is because, again, you don't type the variables. The types are inferred in Python, right? So if I hover over this first number, it says that that is a string, right? Even though I use number in the name, that doesn't mean it's a number, right? That means it's whatever this type is. And this method returns a string. Because this returns a string, this variable is going to be of type string. Same thing for second number. And then same thing for sum, because what I've done is I've added two strings. The add operator is smart enough to know that if you're adding two strings, you actually are intending to put the two pieces together, right? First with second. If you're adding two numbers, it is smart enough to know that you're looking to actually sum them. One question that came in real quick, before I lose it, can Python be used like HTML, or can you use CSS in web development? There are platforms, Flask is one, for example, that you can leverage to build out the APIs and websites using Python as your backend. A lot of times what you'll do is you'll combine that code with CSS or HTML, or your Python code might generate CSS or HTML, but absolutely you can use Python to build websites. Okay, so how do we fix this, right? We intended to actually do a numeric addition, but instead we got a string concatenation. Well, what I can do here is wrap this in another method that is going to take string input and convert it to an integer, a whole number, right? And then similarly, I can do the same for this one. Now, with that in place, if I hover over here, you see that now first number is seen as an int. Second number is seen as an int. Sum is seen as an int because I'm adding together two ints, right? And when I run this code again now, I enter 42 and 99, I get my expected result. Now, what if we wanted to come up, down here and make this a little bit more user-friendly, like sum equals. Let me run that. Wow, we got an error, right? And this you might get sometimes, right? It's a runtime error, right? This runtime error says, hey, wait a minute, you tried to concatenate a string with a number, and Python doesn't like that, right? So just keep that in mind, right? As you're combining variables of different types, be aware of the type inference that Python leverages. Be aware of the context of that particular statement. The syntax plugin is pylint. And then it's the Python VS Code. So what we can do here is actually convert this back to a string. So when I save this and then rerun it, right? Enter the first number 42, the second number 99. And now we have a more friendly formatted result, right? Sum equals 141. We're going to run out of time. I'm not going to be able to run into the challenges, but I do want to cover off on one thing real quickly. Let me clear this and run this again. If I enter for the first number 42, and I enter for the second number the letter A, it's going to throw an exception, right? Because again, this was expecting an int or numeric input. Here I have given it a non-numeric value, right? And so it errored out. This is something you're going to have to think about as you're working through, and unfortunately we don't have time to get into it, but there are loops, there are conditions that you can check, right? You can build into your code data validation that checks to see if the input is valid, and then reprompt the user if the input is not valid. Well, just to show you sort of one kind of neat thing that you can do here with Python, one thing I can do is I can use my pip, my package manager for Python, and I can install something called py input plus. This is an example of one of those libraries that you can add, right? This is an external library that I didn't write, someone else wrote, but I can pull it into my code. I use pip, the package manager, to install it, to make it available on my system, and then to make it available in my code, I can simply import it, and I can give it an alias, so I don't have to, because you'll see here, I'm going to need to reference this when I call some methods in a bit. What I can do here then is I can type pyip dot input int, sorry, input string. Oh, no, this is int, sorry. So here I'm using a method that's defined by another library that I am importing into my code, right? I can do the same thing here. pyip dot input int, and then I don't need this trailing. When I do this, right, when I run this now, I can type 42 for my first number. If I type the letter A, it's going to say, hey, wait a minute, A is not an integer. And it's going to ask me again, right? I didn't have to write the code to do that. Now I could have, right? I could have written the code to test that value and then to turn around and reprompt the user. But here, by using an external library, I'm able to very quickly integrate this capability into my code. If I enter a 1.23, that's not an integer, right? I want a whole number. And then I can enter 99 and we get everything operating the way it did before. So the library was plus that you might find helpful. Just have a couple of minutes left, so I wanna be able to finish off real quick. The challenges we didn't get a chance to go through, but good news, right? So what did we cover? We covered some foundational concepts. We talked about setting up our development environment, and then we did some practice, right? And that's, again, one of the keys to learning Python is practice, practice, practice. Next steps, right? For you, I would recommend, right, this, grab this again. Take a walk through all of the modules of this, right? The rest of the modules of this will start to introduce you to the if, else statement, right? It will give you additional opportunities and options for manipulating data. Definitely, this, in my opinion, would be a great place to start for a beginner who is just getting started in Python. So I would definitely, go ahead and take advantage of that. And then the other thing I might mention is, again, that first, I'm sorry, that www.python.org beginner's guide under documentation. So I'm going to stick around for a couple of minutes if people have additional questions. If you could please hit this survey link, aka.ms/reactor/survey. Use event code 11645. This is your opportunity to tell us what kinds of things, what kinds of sessions would be helpful for you going forward, right? So that we can gear these in a manner that really meets community members' needs. So please take advantage of that. It would be great, very appreciated. And again, it's been a pleasure being here with you. I've had a great time. I hope you've learned a lot. If there are any more questions, please post them. Otherwise, we can call it a day. Have an awesome rest of your day. And again, looking forward to maybe another time to be with you.